we look at our final design, if my mouse is on the right hand side, my D on the left hand side at Danny doesn't really move too much. It isn't really distorted. It's only really when my mouse gets really close to the point that's when it starts to move a lot more. And it's only as I get closer and closer to the D, then that really does get distorted. So what we need to work on next is basically how do we find out the distance from the point from the mouse. So at the moment we have create vector, and at the moment it just moves it around. We don't want it to be create a vector of our distortion. Instead, we want to first of all calculate the distance. So before we do any distortion, how far away is the point from the mouse? So we're going to create a new vector above this. We're going to do constant called distance. So the distance and distortion are different. We're going to work out literally the difference between the point and the mouse currently. So here what we're going to do is we're going to create a new vector. The vector is going to be mouse x minus point dot x. So the mouse x is across minus the point on the page itself. And secondly, we also need a mouse y minus point dot y. So this is going to be the distortion on the page itself. Now, if we just make the distance exactly equal to the distortion, let's see what happens. So if I just make this equal to the distance, how does it look? So at the moment, if I scroll on the page, it kind of doesn't get very, you can kind of see actually there's a circle following us around the page. Now, why does that happen? Well, basically, all of our points are exactly the same distance away from the corner. So it's just taken away from this. So maybe we need to switch this around a little bit. So we've got the wrong way around maybe. Let's try the other way around. Point minus x, point dot x minus mouse x. So now we'll see them all in a line. Looks a little bit weird. So let's try it in the other way on the y. So let's change this one too. So mouse y. So now what we'll see is this kind of being twice as large. If I put it right in the middle, you can kind of see the reason why. So the point is actually double the size away from the corner. Now obviously this isn't what we want. We want the furthest away thing possible to not have any kind of movement. So what we want to do is take this distance and multiply it by something else. So basically the further away it is, the further away it, the less distortion it should get. So on this distance, what we're going to do is multiply this, mult, which is part of p5.vector, which I can find down here. I can do not mag, but multitude. Where is it gone? Mult. There it is. We're multiplying this whole thing by, let's put for now just something like 0.4. So what happens if we put 0.4? Well, again, it's gone a bit smaller. Again, if we make this a little bit smaller too, it's kind of in the right place. So almost there. But what we want to do is actually take that original distance and basically factor it in based on how far away it is. So again, a little bit of math in here. What I'm going to do is multiply this whole thing by 60, which just sounds like a lot. And basically we have this kind of like these points kind of flicking around the page, which is a little bit too much. But then what we're going to do is divide 60 by the distance. How big is this actual distance? The magnitude of this vector. So the further away it is, the less distance this will be, because if 60 divided by a big distance is a small number. So again, this was a bit of playing around with this to get this looking correct, but we have this kind of magnifying effect now. If I make that number bigger up here, so something like 60 can go to 100, then this is even more magnified, even at the edges. So we have this kind of control over how this looks. Again, I might want to kind of reduce that down a little bit more to something like 50 to see how that looks. That looks pretty good. Maybe 60 was right in the first place. But what we've done here is we've created the distance away from the point from the mouse, then taken that distance and then multiplied it, that whole kind of vector, by 60 divided on how far away it actually was. And what that gives us is some kind of distortive effect. Now again, what we can do is use these two things in our shape. So I'm going to copy this and I'm going to paste this further down, and just in the same way, I'm going to add distortion dot x, and on the point, I'm going to add distortion dot y. And now what we can see is these lines have the same kind of effect. We get this same kind of thing going on here. So what we've done quite quickly, I know it's a little bit of math in here, but what we've done is we created a vector based on how far away the point is. We've then taken that point as distortion and then divided it or multiplied it by how far away it should be. So the further away it is, the less multiplication this distortion has. The closer it is, the higher the distance gets multiplied, and therefore there's more distortion.